Welcome back to my channel Techno Education Academy. In this video lecture, we will discuss the basic concept of fluid mechanics, compressibility and bulk modulus. Let us start. First of all, what is compressibility? Compressibility is the reciprocal of bulk modulus of elasticity. It is denoted by K, which is defined as the ratio of compressive stress to volumetric strain. It is also the reciprocal of bulk modulus of elasticity. Let us try to understand the concept of compressibility. Here we are considering a piston cylinder device. Here we applied the force on the piston. So the gases enclosed inside the system, it will be compressed. Here we are considering the initial volume is V. And after compression, the volume will be changed and it will become dV, and dV is the change of volume after compression, because we know that any of the gas, it is compressible in nature, and whenever we compress the gas, at that time the volume of the gases will be decrease and the pressure of the gases will be increases. So for that, here we are considering P is the pressure of gas when volume is V. This V is specific volume. Let the pressure is increased to P plus dP, because we know that the concept of gases. Okay, in case of a gases, whenever we compress the gas, so its volume will be decreased and pressure will be increases. So let us consider the increase of pressure is P plus dP and the decrease of volume is V minus dP. Then increase in pressure dP, it is measured in kgf per meter square, and decrease in volume equal to dV. So volumetric strain equal to change in volume upon original volume. And here we are using negative sign, because whenever we compress the gas, at that time its volume will be decreases. So here we are using negative sign, and this negative sign will represent the volume of the gases. It will be decreases after compression. So this negative sign means the volume decreases with increase of pressure. Now bulk modulus, we know that bulk modulus means increase of pressure upon volumetric strain. We have already discussed in first slide. What is bulk modulus? It is the ratio of change in pressure upon volumetric strain. So the change of pressure is dP, and volumetric strain, we have already derived the equation, volumetric strain equal to minus dV by V, and this negative sign will represent the volume of the gases will be decreases with increase of pressure. But we know that compressibility means it is the reciprocal term of bulk modulus. So compressibility equal to 1 upon K. By using this equation, we can solve the example related with the compressibility and bulk modulus. Now we will derive the relationship for bulk modulus and pressure for a gas. We will derive this relationship for two processes. The first process is isothermal process and the second process is adiabatic process. So let us consider the first process, isothermal process. First of all, what is isothermal process? Isothermal means throughout the process, temperature remain constant. It does not change. Okay, it is called isothermal process. It is also known as hyperbolic process or constant temperature process. We have already derived the relationship between the pressure, volume, temperature, derive the equation of work done, internal energy, enthalpy for constant temperature or isothermal process in my thermodynamic playlist. If you want to clear your fundamental related with the different non-flow processes, then you can visit this playlist and watch this video series. But we know that according to ideal gas equation, PV equal to mRT, where P is the pressure, V is the volume, M is the mass, R is the gas characteristic constant, and T is the temperature. So in this equation, R is already constant, T is a temperature. For isothermal process, it does not change, so it remains constant. So we can also write this equation dV by M equal to constant, because R is constant and T is also constant for isothermal process. But we know that density equal to mass upon volume. it is the ratio of mass upon volume. So here you can see that it is volume by mass. So we can also write 1 upon rho according to this relationship. So P by rho equal to constant. And volume by mass, it is also known as specific volume. But we know that specific volume is inversely proportional to density. So P by rho equal to constant. Or we can say P into specific volume equal to constant, because specific volume is inversely proportional to density. Specific volume means it is the ratio of volume divided by mass, and density means it is the ratio of mass divided by volume. So continue from previous equation, PV equal to constant. So here you can see that P is also variable, and specific volume V is also variable. So P and V both are variables. So we differentiating this equation. So according to the multiplication rule, okay, the first term is remain constant and the second term derivation plus the second term remain is constant and the derivation of the first term equal to 0. So P dV plus VdP equal to 0. Now we will shift this term on right hand side, so it will become negative. So P dV equal to minus VdP. Now we make the object P. So P equal to minus VdP upon dV. So dP equal to P dV divided by V. Substituting this value in equation of bulk modulus, K equal to increase of pressure divided by volumetric strain. So we have already derived the equation of dP. So put the value of dP from this equation in equation of bulk modulus. So here you can see that minus term is there. Here in denominator minus is also there. dV by V, here dV by V is also there. So it is cancelled out. The remaining term is P. So K equal to P for isothermal process. So here we prove that bulk modulus is equal to pressure for isothermal process. This is the relationship between bulk modulus and pressure for isothermal process. Now we will derive the relationship between bulk modulus and pressure for adiabatic process. We know that according to adiabatic process, PV raised to gamma equal to constant, or we can say PV raised to K equals to constant. In some of the reference book we are using K, or in some of the reference book we are using gamma, and it is called Adiabatic Index, and it is the ratio of Cp by Cv. So PV raised to K equal to constant, or we can say this is a specific volume and it is the inversely proportional to density, because density equal to mass upon volume and the specific volume means volume divided by mass. So we can also write E by rho raised to K equal to constant. Same as here we differentiating this equation according to the multiplication rule. The first term is remain as it is, and the derivation of the second term plus the second term is remain same, and the derivation of the first term equal to 0. So the derivation of the V raised to K. So according to the fundamental of differentiation rule, the differentiation of x raised to n equal to n into x raised to n minus 1. So same as here, V raised to K is there. So K into V raised to K minus 1. So here the derivation with respect to specific volume, so dV, plus V raised to K, it is a constant term, same dP equal to 0. We can also write this equation in this form. So our objective is to keep out the common term V raised to K minus 1. So here we multiply with V and multiply with V raised to minus 1. Okay, so we can also write V raised to K minus 1 into V. Okay, and according to the fundamental of mathematics, okay, whenever the base is common, so at that time this is a addition or subtraction of index. So whenever we simplified this equation, V raised to K minus 1 and V raised to 1. So minus 1 plus 1, so it is cancel out, so v raised to k. So we are getting this equation. So here v raised to k minus 1 is common term, it is cancel out. So the remaining term is p into k into dv plus v into dp equal to 0. So whenever we shift this left hand side term to right hand side, so it will become negative. So p into k into dv equal to minus v into dp. Further we simplified this term. So p into k equal to minus vdp divided by dv. But we know that increase of pressure divided by volumetric strain. Okay, dp. Here you can see that v. Okay, it is in numerator. So it is the denominator of the denominator. Okay, we can also write down in this form. We can also rearrange this equation dp by dv by v, where dp is the increase of pressure and dv by v is the volumetric strain. So instead of this term, we can also write k. It is called bulk modulus. So bulk modulus equal to p into k, where capital K, it is the bulk modulus, and this small k, or we can say gamma, it is called specific heat ratio, or we can say adiabatic index, and its value is 1.4 for adiabatic process. Okay, we have already derived this equation gamma equal to Cp by Cv in my previous lecture of thermodynamics. Okay, you can watch these videos if you want to clear your fundamental. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends.